All right, check if you can remember this. It's a review from yesterday. We work at this example on the quiz. If you have 5 exponent x equals to 625, how do you solve it? How can you find the solution for x? Well, in this case, it's kind of simple because you are able to factor out 625. 625 is 5 exponent 4. You can substitute, you can change. You can make 5 exponent x equals 5 exponent 4, right? And then you compare the exponents. You're gonna say that one exponent and the other one, on the left hand side of the equation, and the right hand side of the equation, they will be the same, right? So after you compare the exponents, what is the value of x? What is the answer? The number that's missing here on the last line. Help me, send me your messages, tell me what is the number that is missing. And I will invite, I'm gonna ask a couple of students as usual to help me. You all agree? Maybe 4 is the right answer. I'm not sure, but maybe 4 is the right answer. If we compare 5 exponent x equals to 5 exponent 4. So compare x with 4. We need to have them equal, right? For this to be true. So yes, that's right. 4 is the right answer. Thank you, Ariana. Thank you, Kalia. Excellent. Very good. 4 is the correct answer. Now we can move on. And on this case, on this example, we could manage to find the answer because we are able to factor out 625. We know that 625 is 5 exponent 4. But most of the time, it will not be that easy. We're going to have a number that we cannot factor out like this. We cannot have the same base and compare the exponents. How can we solve if we have this situation? And that's what we will do today, okay? We will learn how to use graphing to solve equations involving exponential functions. Graph of exponential functions. First of all, let's understand a few properties of these graphs, and after that we will draw the graphs. But don't worry, I don't need you to draw the graphs on paper and pencil, okay? I need you to use your computer, your app, and the graphing calculator if you have. Check this out. The graph of an exponential function is going to be defined by f of x, which is equals to b exponent x, right? And x is the variable. If we have b is a number, is the base. If you have the base between 0 and 1, is greater than 0 and less than 1, we will have what we call a decay. A decay, the function starts high, with a high value, and will go down, down, down very quickly, and then reach 0. This is a decay. And we have a decay again when b is between 0 and 1. So 0 less than b less than 1. Okay? The other situation we will have is if the function f of x equals b exponent x, if we have b, the base, greater than 1. If it's greater than 1, we will have something like that. And this is called growth. Is when b is greater than 1. Okay? Those are the two situations we will find, depending only on the value of b, we can have a growth or we can have a decay. One of the applications of exponential functions is to manage money, to manage your finances. And a quick question for you. If you want to manage your money and you want an investment, what kind of function, what kind of behavior do you want from your investment? If it's applying exponential function, do you want a growth of your money or do you want a decay of your money? What do you think? Do you want a growth, your money to grow, or you want your money to decay? What is your choice? This is an application of exponential function to manage money, to manage finance. And answer it. And we're going to work on a few examples. First of all, we have graph the functions f and g. We have the function f on letter A. Okay, letter A, function f of x equals 2 exponent x. I don't want you to work on paper. We don't need to work on paper anymore. We are graduating. We need to work. We need to know how to use computers, right? Computers and calculators. That's the reason we're going to use our graphing calculator. You remember this? GeoGebra. So open your graphing calculator online, or if you have a real graphing calculator, a physical one, you can get your graphing calculator and type here on the first line. If you're using GeoGebra, let's type the first function, and we can write this as y equals 2 exponent x. Okay, so y equals 2 exponent x. Enter. And let's see the graph. That's it. Let me expand. You can see the whole thing. Check this out. This is the graph. Let me use a different color, blue. And this is definitely a growth because b is equals to 2. b is greater than 1. So we have a growth. Now let's check another one. Another example. We have b. Letter b. G of x equals 1 over 2 over x. And we will write down on the graphing calculator y equals 1 over 2 exponent x. Okay, this is what you're going to write on the graphing calculator. Y equals 1 divided by 2 exponent, not over x, sorry, exponent x. And let me expand. Yes, look. I'm going to use a different color, red. Now the function in red is a decay because b is 1 over 2, is less than 1. Now we're going to have a decay, right? My last question, the last question I have for you is, let's say we want to solve this equation. Check out the equation. We have 2x, 2 exponent x, and I want to find the solution for this equation here. Make it equal to 1 over 2 exponent x. See? I'm making f of x equals to g of x. 2 exponent x equals to 1 over 2 exponent x. What is the solution? What is x equals to? Can you find the solution for this? Can you tell me what is the solution? Let's look at the graph. if you look at the graph, what is the solution? Can you spot, can you see where the graph, where both functions, the blue one and the red one, where do they have the same point, the same x and the same y? The same point, where is it? Which point here have both colors, blue and red? Can you tell me? Which point have both colors, blue and red?
0.1.
Yes, that's right, perfect. Excellent. Very good, Jacob. Yes. Let's click here. The intersection, right? The intersection between the two graphs, between the two functions. X equals 0, x equals 0, y equals 1. And you can click on it, you're going to find x equals 0, y equals 1. So the answer, the solution for 2 exponent x equals 1 over 2 exponent x is x equals 0, the intersection. We're going to work on this, like this, on the quiz. Thank you, Jacob. Excellent. Very good. Any questions? Tell me if you have any questions, any comments, any complaints, anything at all. Let me zone this. Oops, no. What do you think? Maybe we can now repeat this work on the quiz. This kind of procedure that you're gonna make two functions and find the intersection is very useful to solve any kind of equations. You can make one function is the left-hand side of the equation, another function is the right-hand side of the equation, and then you find the intersection, which is going to be the solution. Very useful to solve any kind of equation using the graphing calculator. All right, no questions? Maybe we can move on. You can find a good approximation by using the PhotoMath app. You take a picture of the equation 4 exponent m plus 1 equals 200. So take a picture, and the app will give you a solution, an approximation for m. And m equals, and write down here, m equals 2.82193. And this approximation, because is going to have infinite decimal places. Then you plug in m, 4 exponent 2.82193 plus 1, and you're going to find 50.9, and then lots of decimal places as well. 50.9 and lots of decimals. That means the answer is a bit greater than 50.9. It's a bit more than 50.9. Okay? So the right answer, the exact answer, is greater than 50.9. So you can find a good guess if you can calculate an approximation. All right, but I will show you how to calculate the exact answer. We can do it because 4 exponent m plus 1 is equals to 200. And we can divide both sides by 4. Divide by 4 and by 4. This is 4 exponent 1, right? There's a property that you can move this from the denominator to the numerator by changing the sign of the exponent. It's going to be a negative. So you have 4 exponent m plus 1 minus 1. Remember this? Which is equals to 200 divided by 4? 50. And m plus 1 minus 1 is m. 4 exponent m equals 50. But we want 4 exponent m plus 1. And for 50 plus 1 is 51. This is the right answer, 51. Unfortunately, I think we don't have a winner. We all guessed 4 or 5, and maybe you followed the lead. Maybe some of you were thinking about this number, a number closer to 50, but thought, no, everybody is answering 4, everybody is answering 5, I will follow the lead. No, you have to follow your heart, to follow your instincts, and the right answer is 51. On the quiz, we will solve for x by graphing, round to the 5 decimal places. Today I'm asking 5 decimal places because it is the same thing the app will give you. The app will already give you 5 decimal places, just to make it easier, okay, for you. 5 decimal places. Okay. And let's work on the first one. 8 exponent x equals to 21. So we will do this by graphing using our graphing calculator. Let me clear this up. Clear, erase everything. Okay. The left hand side of the equation, you're going to write on the first line, y equals 8 exponent x. Okay. Enter. The right hand side of the equation, you're gonna write on the second line, y equals 21. Enter. Now you have 2 graphs. You will find the solution by locating the intersection. Let's find the intersection. And the intersection is up here. Check this out. Let me just expand, show everything, and this we have the red one, and let me change the color. This is the blue. The intersection between the red graph and the blue graph is this point. X equals 1.4641, and we have 0.5. If the next digit is a 5, we have to round up, or 1. This is going to be the right answer. X equals 1.46411. So here x equals 1.46411. Good morning, Adrian. All right, so now try by yourself. What you have to do is represent on each line. Each line is going to be one side of the equation, and then you find the intersection, which is going to be the solution. Okay, and you can click on the point to find the number, the value of x and y. We just need x. X is the first number. Okay? I will give you I can ask you to give me 1 minute. I will check attendance, and after that you can work together. Clean this. Let's work on. I can take the chance to use for letter B, 6 exponent x. So the first line is going to be 6 exponent x. The second line is 39. So change here by 39. Enter. That's it. Now find the intersection. The intersection is going to be up, 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 up. We need 39 right here. Click on the intersection point. You have the answer. X equals 2.0447. And that is, we need 5 decimal places, right? 5 decimal places. So for letter B, 2.0447. Okay? This is letter B. Letter C. Kalia asked about letter C. No problem. Let's work on letter C. Clean this up. And letter C is 3 exponent x plus 1. So let's change this. This is 3 exponent x plus 1. Let's change the second line. The next line is 5 exponent x. So enter. And now we have, oops, the intersection will be where's the intersection? We will find the intersection. One thing you can do, if you cannot find the intersection, there is a function you can use. Click here and intersect and select this graph and this, and then you're gonna find the intersection. Oops. Okay, intersect this, this, and this, and then you have the intersection. 2.x equals 2.15066. All right. Remember, after you check using the graphing calculator, go over the app. You just need to take a picture, scan, and the app will give you an answer. You will be confident. Makina, for letter D, you will have negative 0.553295. And the other ones you can check with the app. Thank you, Makina. Thank you, Kalia, Cynthia, Jacob, Chris Diel. Bye-bye, Adrian. Bye, Ewell. Have a great day.
Have a great day, sir.
Bye-bye, Maddie. See you tomorrow. Thank you. Oops.
Mister,
Yes.
what is the bell work again?
The bell work is 51. 51.
Okay.
51. Thank you,
Thank you.
Evelyn. Have a great day. Thank you, Ewell. Bye-bye, Jacob. Thank you.